Good morning, my YouTube viewers. It is Crystal here. I haven't made a video in a while because I was busy working on some other things. And because I was busy working on other things, I couldn't really make a video. But I might, for the short term, I might start making some more videos. And the reason for that is because I have to get some documentation that had expired updated. And then whenever I get that documentation updated, then I'll be able to carry on doing the work that I had previously done. So you may see some more videos from me soon. So the video that I'm working on today is going to be on a Kaggle competition, and it's Kaggle Playground Competition, Season 5, Episode 4. And what we were supposed to do is we were supposed to predict on podcast listening time. So the first model that I used was a linear regression model. And the linear regression model scored okay, but it scored slightly worse than sklearn's neural network multi-layer perceptron. So I decided to go ahead and make the video on sklearn's multi-layer perceptron. And the reason for that is because I do a lot of videos on linear regression, and so I just thought for a change we'll do the multi-layer perceptron. I did try to do another video for a Gaussian model, but my computer didn't have enough power and it caused the program to crash. So as much as I would have liked to have made this video on the Gaussian model, I couldn't do it. So you just have to settle with multi-layer perceptron regressor. So this is April 2025 playground competition with Kaggle. The problem statement is predict on podcast listening time. So the first thing that we want to do is we want to import the libraries that we're going to be using to execute the program. So we're going to import NumPy as NP, which is the numeric library. We're going to import Pandas as PD, which is the data processing library. We're going to import OS, which goes into the operating system and retrieves the files. We're going to import sklearn, which is Python's machine learning library. We're going to import PyLab, which we're going to use that to make a QQ plot. And we're going to import scipy.stats stats, which is Python's scientific library. And we need to use that to create a QQ plot. We're going to import matplotlib.pyplot as PLT and Seaborn as SNS, which are the visualization libraries. So now what we're going to do is we're going to use OS to go into the operating system and retrieve the files. And we've got 3 files, being the train, test, and sample submission. Then we're going to use Pandas to read the files. So when we read the files, we're going to convert the CSV files to data frames. And the 3 data frames are going to be train, test, and submission. So you see, here's the train file. It's got a lot of information on it, but the very last column of data is the listening time minutes, and that is the target. We checked info, and you can see we've got integers, floats, and objects. So this is a varied data set. And since it's a varied data set, we're going to have to encode the ordinal objects. We checked for null values. You see episode length minutes has a lot of null values, and guest popularity percentage has a lot of null values, and the number of ads has one null value. We check test. Test file is very similar to the train file, with the exception it does not have the podcast listening minutes, and that's what we're going to be predicting on. We're going to check for null values. You see the episode length minutes, we have null values, and guest popularity percentage, we also have null values. So we check our submission file, and this is the format that Kaggle wants to see when we submit our work to Kaggle for scoring. So we're going to drop the null values. So what we're going to do is on the trained data frame and the test data frame, we're going to drop the columns episode length minutes and guest popularity percentage. And we're going to do that because it had lots of missing values in it. And because it had lots of missing values in it, I just thought it wasn't going to do any good to use the mean or the median or the mode to impute the data. So I just deleted those two columns. And now we're going to impute the number of ads. And then so we're going to take the number of ads in the train set, and we're going to make it the mean. And whenever I was talking about dropping columns, one thing that I forgot to do is I forgot to drop the columns with the index. That might improve the score if I drop the columns with the index. So when I finish this video, I'm going to go back and drop the columns with the index and see if that improves my score. Because you don't need the columns with the index, because the reason why you don't need the columns with the index is because Pandas automatically indexes every row of data. So we're going to analyze the train. We're going to create a histogram with Matplotlib, and we're going to analyze the train. And you can see that it's not really a normal distribution. It's a skewed distribution, skewed on the right-hand side. But that's your analysis of your target, which is the podcast listening time. So now we're going to analyze the host popularity. So we've got the host popularity, and that looks like a uniform distribution. So now we're going to analyze the genre. So you can see the genre, and you can see you had some genres had more podcasts than others. Like the lowest genre was education. So I guess people weren't interested in education podcasts. Now we're going to check on the publication day, see if that makes a difference. And the publication day are very close. I think Sunday was the highest publication day, and Monday was the next highest publication day, which I'm quite surprised because Saturday wasn't really up there in the top, and I would have thought that a lot of people would be publishing their podcast on a Saturday, but maybe they just think that people are busy doing things and they won't have time to listen to the podcast, so they decided not to publish it on that day. But the Sunday was the most commonly used publication day. Now we're going to check publication time. And again, the publication times were, pretty close. I mean, the afternoon and the morning was lower than the night and the evening, but it wasn't that much lower. So now we're going to check the sentiment of the histogram, and you can see the sentiment is pretty close in values. So now what we're going to do is we're going to encode the columns. So we're going to import sklearn's ordinal encoder to do that. And so every column that is a object column is going to be encoded. Now we're going to use Seaborn to create a heat map. So you can see that the heat map we've created, it means that because there's so much dark in this heat map, it means that these columns are not highly correlated. And so that was interesting. So now we're going to define our X and our Y variables. So Y equals train.pop, listening time minutes, X equals train, and X test equals test. And now we're going to use sklearn's standard scaler to scale the data to convert it from all of the data from 0 to 1. And the reason why you scale the data is because it's easier for the machine learning model to work if the data is closely dimensioned. Now we're going to use sklearn's train test split to split the data set up into training and validation sets. And now we're going to define our model, which is an MLPRegressor. Activation is read-blue, random state is 42, max IDRA is 2000, and total equals 0.1. And we had a 0.02% accuracy. And then we're going to predict on the validation set. So you can see the prediction. We check our RMSE, which is our root mean squared error. And our RMSE is 26.79. We're going to do a histogram of YPRED. And so this is your histogram of YPRED. It's not quite a normal distribution. It looks a bit skewed to the right, but it looks okay. It looks better than it looked whenever I made the model, the linear regression model. So now we check our values. You can see the values of YPRED and compare it to YVal. So now what we're doing is we're creating a QQ plot. And so you can see that the YPRED pretty much follows a distribution line. So that's good, a normal distribution line. So now what we're going to do is we're going to plot the YPRED against the YVal. And you see it doesn't look fantastic. And that's why I tried to use a Gaussian model, but I didn't have enough memory in my computer and it caused the website to crash. So that doesn't look fantastic, but what can you do? Well, there are things you can do, because that's why they have people who are machine learning engineers, because a person who is a machine learning engineer would probably have the skills to be able to correct that. So now we're going to predict on the test set. And then after we predicted on the test set, we're going to prepare it for submission to Kaggle. And when I submitted it to Kaggle, I had a score of 26.87146. So I was about 300 and something on the leaderboard, which isn't too bad. So that concludes this video. If you like my video, please like and subscribe. I'm going to keep I'm going to give you a copy of the web page, so you can look at the web page if you would like to. And thank you for watching my video. I look forward to making some more videos for you in the future.